Good morning, class, and welcome to this lesson on Kinematics 15, Projectile Example Problem number 3. Today we will be able to solve for how far an object falls in the following problem. This is going to look pretty much like the other problems, but we're going to be looking at it from a different perspective. And I'll show you how in a minute. So here's the problem: a person with a rifle. Okay, a person with a rifle. Okay, so a person with a rifle, big compressor right there, fires a bullet. Okay, or excuse me, does not fire a bullet, is aimed directly at a target. So this person is aimed right on the crosshairs at the target, and this person is standing 75 meters away. This person is standing 75 meters away. They are aimed directly at the target. They fire the bullet, and due to gravity, the path of this bullet is going to be lower than the target. So the question is, what is that distance? How far does it fall below the target if it's aimed directly at the target if it fires at 180 meters per second? We know from previous problems that the one thing that connects both the x and the y axis is time. Okay? Before we used the y direction to figure out how long something would be falling for, but in this situation we can use the x-axis, and that's how this one is different. Okay, in this one we know when this thing is fired, the velocity, the initial velocity in the x direction equals 180 meters per second. Okay, and we know that the distance in the x direction equals 75 meters. So this becomes pretty simple that v equals delta x over delta t, or delta t equals delta x over v, or in other words, 75 meters divided by 180 meters per second gives us a time of 0.416 seconds. So this thing is in the air for 0.416 seconds. So now the question is, how far does it fall? So we're looking for delta y. So we know that t equals 0.416 seconds. Delta y is our unknown. A is equal to negative 9.8 meters per second squared. And the initial velocity in the y direction is equal to 0. So what formula can we use in order to solve this? So we just use this formula right here. Delta y equals the initial velocity in y times t plus 1/2 at squared. This is equal to 0 because the initial velocity in y is equal to 0. So delta y equals 1/2 negative 9.8 meters per second squared times 0.416 seconds squared. So we get a distance of 0.85 meters. So this thing's going to fall almost a full meter below the target from 75 meters away because this person did not aim above the target and bring the bullet down. They aimed straight across and it went too low. That is just another example of how another example of a projectile motion problem, but in this case, we use the x direction first as opposed to the y direction, which is a little bit more of an uncommon question, but still common enough that I would like to make a video on it because it is asked here and there. That's it.